You're already a time traveler moving forward through time at 1 second per second. A bit boring, sure, but it's a starting point. The real fun begins when we talk about actual time travel, riding dinosaurs, or high-fighting Einstein. Begin with something important. Time isn't just something that passes, it's a dimension, like space. We believe our universe has 4 dimensions, 3 of space, left-right, forward-backward, up-down, and 1 of time, all woven together into something called space-time. What you experience as time passing, your life unfolding moment by moment, is really you moving along the time dimension. But unlike space, where you can move in any direction, time seems one way. You get older, never younger. You can't take shortcuts, but that's an illusion. In fact, you have more control over how you move through time than you might think. To explain this without too much complicated math, we'll simplify a bit and mildly annoy some physicists. Just keep in mind, reality is even stranger than this. Here's a strange rule. Everything in the universe moves through space-time at the speed of light. Your total motion through space-time is a combination of how fast you're moving through space and how fast you're moving through time. Even if you sit perfectly still in space, you're still hurtling through time, barreling into the future at nearly the speed of light. You can actually slow down your motion through time by moving faster through space. But your combined motion through space-time always adds up to the same total speed, the speed of light. For example, if you could somehow come completely to rest in space, which isn't really possible, you'd be moving through time at the maximum possible rate. On the flip side, photons, particles of light, move through space at the full speed of light, leaving zero motion for them through the time dimension. From a photon's point of view, if it had one, no time passes between leaving the sun and hitting your eye, it's instantaneous. Again, reality is even weirder. Technically, we can't define a reference frame for photons like this, but it helps illustrate the idea. So, move faster through space gives you move slower through time. Move slower through space gives you move faster through time. But always, the total combined speed through space-time remains constant. This leads to all kinds of strange effects and makes real-time travel possible. Real and easy time travel. Imagine a bus driving past you. It's moving faster through space than you are, so it's moving slightly slower through time than you. In physics terms, the bus's clock ticks a tiny bit slower relative to yours. If someone else moves even faster, their clock will tick even more slowly compared to yours. The faster you go through space, the less you move through time. This effect is small at everyday speeds, but becomes huge at speeds close to light. And that's where real-time travel comes in. This brings us to a famous example, the twin paradox. Imagine forcing one of 2 twins into a rocket, blasting them through space at incredible speed, while the other twin stays home on Earth. As one twin travels extremely fast through space, they experience time differently than the twin who remains stationary. When the space twin finally returns home, they discover something shocking. They are younger than their sibling by years. Meanwhile, the abducted twin is also probably in therapy for being kidnapped by overenthusiastic theoretical physicists. This is the famous twin paradox, and surprisingly, it makes perfect sense according to the rules of the universe. What's happening here is time dilation, the idea that time isn't absolute, but relative. Your position in time depends on how you're moving through space. With a fast enough rocket, you could technically travel as far into the future as you like, even witness the heat death of the universe, if you had the right technology. But high speed isn't the only way to travel into the future. There's another trick: gravity. Massive objects like planets, stars, and black holes bend spacetime. This bending causes time to slow down near them. On Earth, this effect is tiny. Time moves about 0.00007% slower here than it does far out in deep space, beyond the pull of gravity. Hardly useful for time travel. But near something much more massive, like a black hole, the effect becomes extreme. If we kidnap our twin again and send them near the event horizon of a black hole, time slows dramatically for them. From their perspective, their watch ticks normally, but from an outside observer's point of view, the twin appears almost frozen in time. When they return to Earth, they'll find that far more time has passed here than for them. Once again, time travel to the future, so you can move into the future by going fast or by hanging out near something massive. But honestly, this kind of time travel isn't very exciting unless your main goal is to skip ahead to teleport into the future. It also makes things like building a galactic human civilization very complicated. Even if we developed interstellar travel, every long journey would mean returning to a home world that's aged far beyond you. But what about going backwards? Now that we understand how movement through space-time works, there's a strange theoretical loophole that might allow backwards time travel. In relativity, you always move through space-time at the speed of light. If you move faster through space, you move slower through time. But relativity doesn't strictly forbid faster-than-light movement through space. And if you did move superluminally faster than light, you would actually have to move backwards through time relative to the rest of the universe. This brings us to tachyons, hypothetical particles that could travel faster than light. If tachyons exist, they would exhibit some bizarre properties. The faster they go, the less energy they have. The slower they go, the more energy they need. Crucially, they would travel backwards in time from our perspective. Now we're talking about real time travel. If tachyons were real, you could theoretically send information into the past, maybe even messages to your younger self. You could witness events before they happen, meet your great-grandparents, stop yourself from making that one terrible mistake, win the lottery, or get eaten by a dinosaur. Of course, this opens the door to all sorts of deliciously destructive time paradoxes, but here's the problem. Relativity firmly forbids anything that starts out slower than light from ever reaching light speed. The amount of energy required to accelerate even a grain of sand to the speed of light is literally infinite. Even if you somehow harnessed all the energy in the universe, you still couldn't get there. You can move at light speed, like photons, but only if you always move at light speed from the start. Similarly, if tachyons existed, they would have always been superluminal, never crossing the speed of light barrier in either direction. And sadly, despite the theoretical math working out, we have absolutely no evidence that tachyons exist. Most scientists believe they're purely hypothetical and don't exist in reality. So, for now, it seems that traveling into the past is strictly impossible. No matter how clever or determined we are, the past remains a distant land, locked away. We can look back at it through photographs, films, or our memories, but we can never truly return. It's out of reach forever. While that might feel a little sad, it also means you still have the most important moment of all. Right now, the moment where you actually exist. And ahead of you lies a future that's still unwritten, waiting for you to shape it. In a way, you can time travel to the future simply by living and moving forward. Luckily, shaping your future is much easier than trying to change your past. With the right knowledge and problem-solving skills, you can prepare yourself for any challenges or opportunities that come your way. That's where our friends at Brilliant come in. Brilliant helps you become a better thinker and problem solver. With thousands of interactive, bite-sized lessons covering topics from physics and math to computer science, data analysis, and much more. You can build real, useful knowledge in just minutes a day, making great use of your precious present moments on Brilliant. You learn through doing, exploring concepts by solving problems yourself. For example, their scientific thinking course gets you hands-on with the kinds of fascinating questions we've explored in this video. Each course feels like an interactive workshop, helping you build deep understanding and sharpen your intuition, so you start thinking like a scientist. Kurzgesagt has also partnered with Brilliant to create a series of lessons based on some of our most popular videos, on topics like rabies, mammalian metabolism, climate science, supernova, and more. Each one feels like a one-on-one expansion of our videos, letting you dive deeper and learn at your own pace. Wherever you are, on any device, start to get started with the Kurzgesagt lessons, and explore everything Brilliant has to offer, from and programming to advanced science and math. You can start your free 30-day trial by signing up at brilliant.org/nutshell. And as a special perk for Kurzgesagt viewers, if you sign up through our link, you'll get 20% off your annual membership once your trial ends. But wait, we did find a way to break the laws of the universe and go on a breathtaking time travel adventure. Ready? Well, too bad. Here we go. Look, it's the human era. 12,000 years of human innovation brought to life. It's amazing to see how our ancestors built the foundation for the world we live in today. Let's go even further. Back in time, zooming out on the entire timeline of life. Suddenly, humanity is just a tiny blip. Even mammals haven't been around for very long. Now we're entering the age of the dinosaurs. And if we go further still, we reach the very beginning of it all. You can take your own time travel adventure, right from home with our timeline of human history and timeline of complex life posters. They're carefully researched, expert approved, and designed with great love and care. Get them both to experience the full time travel effect, and to help support everything we do on this channel.